I'm Patrick Coleman. I teach at St. John's College in Annapolis. So our course reading, The Making the Atomic Bomb, will be meeting March 4th through April 1st on Wednesdays from 6 to 8 p.m. I cannot say for sure, I think. So I majored in physics. I did a PhD in physics. And even when I was in college as a physics major, I was interested in learning about the physicists of the early 20th century and sort of what they had done. And so, the title, The Making the Atomic Bomb, it sounds like, well, obviously, it's focused on sort of the Manhattan Project, but the book really starts at the beginning of the 20th century, and traces sort of, you follow and get to know many of the physicists who first studied nuclear physics. And like, to me, that's, like a really compelling, interesting thing. So I don't know. I don't know when I first heard about it. It was put on my mind recently in the last few years because I was talking to a friend about, and in some ways I was just sort of, talking to my friend about the idea of like great books written today, saying like, I think at the time I was reading Thucydides, and I was just saying, do you think that people are writing histories today that are, trying to be something like a great book? And just in the conversation, I think this book, The Making the Atomic Bomb, sort of came up as a history, sort of very much trying to talk about sort of a significant event in world history or in human history, but trying to talk about it in a way that, I guess I'd be hard pressed to say what makes a book a great book. It's very, I don't know, I don't necessarily feel confident wading in on like, this is a great book. But I definitely think at the very least that this is sort of like a candidate. Like I think Rhodes is not just thinking about, that he's thinking about the story on many levels. On like a human level, you sort of see, the human beings who were really involved. You see the world in which they were living and how that affected them. So I think, it was sort of brought back to my mind, and maybe 3 or 4 years ago when I was talking to my friend about, recent books and whether anyone's trying to write a book these days that, aims at this sort of lofty goal. And so I think certainly it's a worthwhile book to read, and to sort of, that it can sustain many kinds of questions and many kinds of readings. I mean, maybe I don't know. Maybe when I first was reading it, I was more interested in like the technical details of the physics discoveries and how they came about. There's something kind of incredible, like the idea, like it was just, various times it's sort of like, well, this idea was unthinkable. The idea that you really get to know, among other people, like Ernest Rutherford, and the idea before there was even the idea of a nucleus in an atom. um, the idea that a light, like I think it's an alpha particle, a very light, um, like helium atom, basically being sent at gold foil, and they bounce back occasionally, and it's sort of like, well, this was unthinkable. Like what could be in the gold foil that's strong enough to bounce an alpha particle back, back directly at the the firing mechanism. And that was sort of like, the experiment that led to the discovery of the nucleus of the atom in the first place. Like the idea that, wow, the positive charge of the nucleus must be packed really tightly close together, and that would be something that accounts for the sort of force needed to send an alpha particle back at the observer, or the experimental device. And so I don't know, like to me, those sorts of stories really stood out to me and got me excited when I was, an undergraduate. This sort of like, wow, no one would have ever thought this was possible, and then someone sees it in the laboratory, and then now other people are like, that's impossible, and then slowly being like, oh my gosh, it is, and that means things are going to be different. Like it turns out our whole model of the atom needs to be rethought, and that happens multiple times, just in the part of the book that we are going to read in the course. It's like, some experiment is reported, and like Niels Bohr or Robert Oppenheimer is like, well, that's impossible. And then sort of like look at it and look at the experimental data and things. And then like within a few days, we're like, okay, it has to be this way. And I can't believe we didn't see it, or, and I think, I don't know, different things have stood out. So like maybe more recently when I read it, I am thinking and seeing more like the kind of small, ordinary details about the various, like scientists stand out to me, like the ways that their science sort of interact with their lives. For a lot of it, there's they can various people are more or less seeing through the 30s, the 1930s, the coming of another great war, and just sort of like the community that scientists have. Like I think to me this seems really true, that science is an activity that can really only be done in a community of people. And so I think that's maybe what's been standing out to me more recently reading it, is how Rhodes shows us not just the individual scientists who are making these discoveries, but the sort of community of scientists that exists, and how how there's sort of these group dynamics within that. Of them helping each other out, and the ways that they work, and just spend their time sort of interacting with the work of their research. It's interesting because I mean, I would say you get to see kind of like generations of scientists. So like Rutherford, the Curies, Einstein, maybe Niels Bohr, are sort of like an earlier kind of generation of scientists, physicists, chemists. And then you sort of see like they have, like the people who are like students who work with them, and then sort of like the like next generation coming into its own as like the generation. So like you see Rutherford have many students and have all this influence, and then in the part that we read, you get to his death, you get to Marie Curie's death, and sort of the next generation coming in. And so it's that to me, I think, is sort of fascinating, seeing generations of scientists, one to the next, sort of like helping form, and then the next sort of generation stepping up um, and carrying it on. Um, I mean, I think Ernest Rutherford is really interesting. He's an interesting character for sure that you get to know. I think Marie Curie also is really sort of fascinating. Yeah, I mean, really, yeah, both of them I think are probably not nearly well known as they could be. I mean, especially maybe with like Nolan's Oppenheimer movie. It's like, well, everyone, like that sort of is like, shows you, like, in some ways, right, during the Manhattan Project, Oppenheimer's already been around long enough to be, in charge of the Manhattan Project. Einstein is sort of like very much sort of almost the generation above. And yeah, you see Ernest Lawrence there. So in some ways, I feel like, like, okay, well, maybe people know a lot about Oppenheimer, maybe Ernest Lawrence, definitely ever, like, Einstein's an incredible celebrity. Yeah, so I don't know, Rutherford, Marie Curie come to mind as people who you don't necessarily know that much about, but you'll get to know really well in reading this book. Um, I think actually, yeah, he's all through the book, and it's really kind of incredible. Leo Szilard is, I mean, I think the book starts with Leo Szilard, and he's just, he's just sort of an incredible, like, personality. Like, he's, a great physicist, but also just always thinking about the, like, societal implications of physics. And he also seems to just be really connecting everyone. Like, he talks a lot to many different physicists, and is a kind of like person who communities, I think, need this, like, people who just are kind of like hubs that many spokes, come out of. Like, Szilard seems like that kind of figure. Niels Bohr as well, I think, is kind of a really heroic person in the ways that he, um, like, helped uh, get Jewish physicists who in Germany and then later in Austria had basically lost all their jobs. That and at some point the Nazi government in Germany said the government won't employ any Jewish government employees. Basically lose their jobs. They, like, the government's not going to employ Jewish people. And so, because the universities were national organizations, there were all of these Jewish physicists who had no job anymore. And so, Niels Bohr, I think, sort of helped spearhead this effort to find them jobs in other European countries and in the United States. Which is, it's sort of like, yeah, I don't know, it maybe emphasizing the communal and aspect of this, right? That, like, he not just, was a great physicist who sort of contributed various models of the atom and the nucleus, but he also was very sort of central in supporting the community of physicists who were studying. And he understood how, yeah, like, there's like a story. I'm probably going on too long, but there's like a story where he's talking to an Enrico Fermi, and Enrico Fermi's wife, I think, is Jewish, and it's looking like in Italy, this, like, Mussolini is going to do the same thing um, of increasingly persecuting Jewish citizens. And so Enrico Fermi is thinking, sadly, that he's going to have to leave Italy. And Bohr talks to him about the possibility of winning the Nobel Prize, of Enrico Fermi winning the Nobel Prize, and the prize money helping support him as a refugee and moving to another country. So the Italian government passed a law basically saying, if you're leaving Italy you can't really take any money with you. And so he like Fermi through Bohr got to sort of learn that if he wanted, it's very likely he will win a Nobel Prize, which came with a large monetary prize, and that this would be something that could help support him as he left Italy and tried to find, tried to like start a new life somewhere else, and it would turn out in America. So I don't know, just yeah, like I mean, yeah, your question about who like what people are worth knowing more about. I think yeah, there's lots of them, and in some ways, yeah, it's sort of this community thing. Like Enrico Fermi's incredible character, as is Niels Bohr, and then just seeing yeah, like the ways that they yeah, I don't know, had to deal with these political uncertainties in their lives in addition to being sort of incredible scientists. Yeah, is really fun. Or I mean, like it's serious and it's sort of incredible, but it's really satisfying at least to like, yeah, I don't know, to see them in this context. Yeah, so I would say the biggest way that the book does this is that the book starts far, or like this, the book starts before World War One. And the part that we're going to read only carries you up to the 1930s, and it sort of because it's roughly the book is three parts, but the third part's much smaller, so it's roughly the first almost half of the book that we're going to read, and it carries you up through the discovery uh, that the uranium nucleus can split into two sizable nuclei. Um, yeah, and possibly, and I think yeah, where the book gets that we're going to get to is just that it's still possible. It's not clear, but it's possible that in splitting into those two nuclei, it releases neutrons. And if it does, there are already sort of physicists who see that possibility and say that means you could make a bomb, like, or at the very least, like that makes a bomb really possible. It makes a sustained nuclear reaction possible because it's like a nucleus or a neutron triggers the splitting of the nucleus. And so if the nucleus splits and then releases more neutrons and you have more nuclei around, they'll split and they'll release even more and you get this cascading chain reaction. So just the even possibility of this happening is where we get to with like where the course will end in the book. So all of that is pretty far before. I can't remember exactly where Oppenheimer like picks up in the story, but in some ways, what we're looking at is a lot of the precursors to these things. There's a lot of the early scientific discoveries, the discovery of the nucleus itself, and then these discoveries of radioactivity, of the various possibilities of what is happening in these radioactive events. Um, so that yeah, I would say yeah, it really is sort of like telling like the much earlier version, like it's sort of Rhodes, and I think it's kind of also, um, yeah, he goes into in different ways things that happen in the First World War that themselves are kind of precursors for the Second World War. So there's a chapter where you learn about like poison gas weapons and the different uses that they've found, like ways it was used in like chemical warfare in the First World War, and ethical implications and the ways that the countries were thinking about these weapons. And it seems to me sort of clear Rhodes is setting it up for you to see that these questions, or at least very similar questions, are going to come up with the use of nuclear weapons. That it's like these new kinds of weapons that in some ways are, uh, yeah, I don't know. That, and we still today, I would say, we do think of them as really kind of different kinds of weapons. We really don't want chemical weapons. We don't really, we make a big distinction between chemical weapons, I think, and sort of like, I don't know what the term is, like ordinary ballistic weapons. And so yeah, I guess, yeah, I would say that the in some ways it is a little like, you will, if you've watched Oppenheimer, you will see, some of the people who are characters there, start out, like you'll see them start to appear in the story. But I would say the story focuses on sort of an earlier, like, run up towards like the 1920s and 1930s, and so in that way, um, yeah, it's a pretty different focus and telling a different part of the story than Oppenheimer is. Yeah, um, I want to say that that there isn't like any kind of prerequisite scientific knowledge needed to read it. I think, yeah, I mean, I think Rhodes does do a good job of trying to explain uh, the science when he encounters it, and I don't think he was writing with some thought of, this book being for specialists. I think he was aiming it at a in some sense, I guess, a general audience. At least I would just say maybe a general audience of people willing to put in the work to read it. So I think, yeah, I would say that I'm hoping that anyone who is interested can pick it up, and maybe it doesn't mean it will be an easy read, but I don't think that there will be need to sort of turn to other books to help explain what we find in this one. Um, not that not that scientific knowledge wouldn't help you to understand it, but just that I don't, yeah, I don't, I mean, to me, I feel sort of, um, one of my goals with this is, I just think that in a, yeah, I don't know, in a democratic republic such as the United States, that, like, people should be able to think about the place of science and the sciences in our society. And so I think, I'm hoping that, yeah, that us reading this book together will be able to sort of think of these things. Like, I guess I just mostly, uh, yeah, I wouldn't want people to feel scared off by the presence of, like, scientific material in the book. I don't think, um, yeah, I think that he writes well enough that any that you can try and just sort of figure out the scientific things he's describing by reading him closely. Um, yeah, so yeah, I don't think anyone should feel that they need to go try to brush up on their nuclear physics or chemistry or any things like this. Yeah. Yeah. Um, I mean, I guess, yeah, like, there's many different, I guess, aspects of, or, yeah, aspects of society and maybe also science that I think come up in this. Um, I mean, one thing that I think is true and is important for people to know, maybe especially for citizens, is that, um, yeah, I don't know, is that, like, scientists and a scientific community is made of people, and that it exists in the broader societies that exist for all of us. So like, in that sense, it's really, I would think that, it's one thing we'll see in the book, I think, is that, um, yeah, I don't know, that in some ways, like, science is just one more place where there are necessarily political questions, and where political questions that touch on many other things, more sort of like, the political questions that aren't primarily scientific are still, I still have, yeah, still have consequences and effects within the scientific community as well. Um, so I think that sort of, those, seeing those things in the book, I think, is illuminating, just on, the fact that science is not like a, I don't know, a totally sort of separate and maybe self-sufficient like human endeavor, but it's really just, it's one that exists embedded in the society that we have. I mean, I think that, yeah, like, a lot of scientific funding is done, uh, is government funded, right? Is a sort of is taxpayer funded, and I think, like, we have to be, citizens should be aware of this, not just, um, I mean, yeah, in some sense, I think, like, science is a thing that we do in a society, or that we can choose to do less or more or better or worse. But in that sense, I suppose it's something that we should be aware of, as going on, as in some ways part of every citizen's business, right? Because it's sort of like, it is an activity, largely an activity of the government, and so if the things that the government does are necessarily for that reason, uh, of interest and import to citizens, like, this is one of them. Yeah, I mean, it's interesting, because I feel like in some ways the ethical questions surrounding atomic weapons themselves are not, at least in the part of the book that we're going to read, do not, really come into direct, focus. Um, but it does seem like, sort of broader ethical questions definitely come up. I mean, yeah, there is the chapter about sort of the use of chemical weapons in war. Um, yeah, in some ways, there's lots of, you see sort of a dramatic tension between, um, like, nationalism and internationalism, to maybe, like, uh, you know, use those words for it. Like, the scientific, these physicists aim at being, and are, like, an international community. And you sort of see in the, even in the First World War, and then also, as it's clear, sort of like the second one is approaching, how the scientists have to grapple with their existence as citizens of particular nation states, um, and as members of this international community of physicists. Yeah, so that's sort of an interesting, dynamic, is, the, yeah, that sort of tension between these two different kinds of community ideals of, being, um, a great citizen, a good citizen of your particular nation, and also being a member of a international sort of community of physicists. Yeah, I mean, I think, like, you do just see a lot of the growing, anti-Semitism in Germany, and the ways that it sort of spreads with, uh, through Hitler's, um, expansion, right? He takes over Austria, the anti-Semitism then goes to Austria. Um, Mussolini starts some anti-Semitic policies because he's now becoming a close ally of Hitler's. Um, so you see, like you sort of see like the actual or these particular physicists who are dealing with this. Some of them have Jewish background. Some of them, at least one of them, sort of um, like had been raised a Christian since she was a child, but was ethnically Jewish and sort of didn't even I don't know, sort of didn't even realize was like she had never seen herself as Jewish, but when the law started to see her as Jewish, and so I think you sort of see these tensions as well. These seem like sort of further ethical I suppose issues you see in the text is the broader communities that these physicists are living in, right? Like these are just general questions in their communities of like that end up having huge implications for them personally and therefore also for their science. Like I mean, Albert Einstein is kind of like a really famous example that you see him dealing with the rise of anti-Semitism in Germany, and there's like stretches of time where people are telling him like it is very likely you might get assassinated publicly in Germany. Like it is not safe for you. He's very famous, and he's very famous, as a Jewish person, and like there's times where he leaves Germany, um, just because like he's worried there an attempt will be made on his life. So I don't know. Yeah, I mean, I guess there's probably more ethical issues I'm not remembering now, but yeah, like there's definitely it's sort of like you watch, I guess, like the things that just play out in the early 20th century um, history, and you watch them play out for a particular sort of subset of people living through it. Yeah, it's a good question. I mean, one of the things that I think is sort of, interesting to see is you get to know and see, like the ordinary lives uh, of, these scientists, and you also get to see sort of like the generational change and movement. You watch someone come up as a student and then begin a career and then sort of make career choices, with who he works for and where he's going to live. So at least in this sense, I think students will see, will be reading about people who themselves start out as students, or we come to know them as students, and then you sort of see them take on their own career and sort of make choices about where they'll go, um, and you get to sort of know at least the field that they're entering, and I think, I mean, at least for myself, I think this uh, is compelling of like when I think of where I was when I was an undergraduate. Like I think I just was sort of like, I don't know what people do out there, like I was like, I just know there's lots, like everyone ends up doing something somehow, but like what does that actually look like? And I think often it just looks like, you go here and you try this, and if it doesn't work, then you go somewhere else and you try something else. And so I think in some ways, just seeing, reading about people who are just doing exactly that and seeing where it takes them, will maybe help, at least sort of help you to see that the question of where do you go in life, when you're done being a student, is one that's always been there, and people have always had to um, answer that question somehow for themselves. And I don't know. I think that might be, that might be something. And you maybe you get a sense. I mean, it really focuses on, I suppose, like physicists, but you maybe get a sense even within the physics community of the time that there's people have different talents, and that like you can contribute your talents in different ways. Like there's um yeah, I don't know, like Leo Szilard and Niels Bohr and Albert Einstein and Marie Curie and Ernest Rutherford, like each one of these people has a very different personality. Like they were all great scientists, but in some ways, like some of them are very personable, were sort of like the hub that connected many other people. Some of them were not, the hub, were much more quiet and reticent, and did I don't know, in some ways, like even the ways that they did the work, like what they contributed could look really different. Sometimes, I mean, I think now I can't really remember for sure. I want to say something like Rutherford would have like dinner parties, or like someone would have dinner parties, and it's just sort of like, well, just the existence of dinner parties actually matters to a community. Like people would meet there, people would talk, like like for like they would talk about stuff in the lab in their other areas of their lives and their social settings. And I don't know, maybe just sort of seeing this sort of, you definitely do see a variety of people. Like you get to know a variety of people in reading this book. And I think maybe, undergraduate students can just even appreciate it on that level, that, like yeah, our human communities and our professional communities have a variety of sorts of people in them, and that can be good, that like a community can thrive because like even, yeah, maybe then I don't know if any of the readers might be if any of these students might be physics majors, but if they are, at least it's sort of like, oh, like you can, there's many ways of being a physicist. And if you're not a physicist or have no aspiration to be a physicist, you can at least appreciate that even in physics there's many ways of being a physicist. So wherever else you might want to go, I'm sure there's many ways of being that, of doing that sort of thing as well. I think science is always, at least to us, is like very present in our lives, and in our, even in the ways that it touches our ordinary lives, even if in other ways it's extremely remote from our ordinary lives. And so I think understanding that, just thinking about what, yeah, what a scientific community consists in, and how it goes about learning the things that they learn, um, is worthwhile for sort of anyone today. It's a thing that's worth, I think, serious thought. And in some ways, I also think it's hard to find venues for that kind of thinking. Like a lot of, in sort of, in most areas of education, like science classes are about learning like the science itself. And it seems to me it's a very important and worthwhile activity to think about this, how sort of science and things in science affect our broader world, right? How not being how like people who themselves are not scientists, have no aspiration of being scientists, nevertheless have to live in a world that is strongly influenced by science and by people in scientific communities. And so I think that I would maybe put this study group forward, or this course forward, along those lines of, it's worth thinking about. Uh, yeah, it's worth thinking about how, I feel like I just keep saying the word science all the time, but it's worth thinking about how like these sorts of discoveries and this desire to simply to understand the world around us can lead to all of these implications, and changes in our ordinary lives. Um, and I think that just continues to exist, it continues to go on. We continue to live in a world where technological developments are unpredictable and can be sort of seismic. Of all of a sudden, we have created something that we never imagined likely, and now we have to live in the world where this thing exists, and so I think that happened with nuclear weapons. That in some ways, it they like nuclear weapons came about just because we realized they could come about, and and so they did. And so I think like that's maybe not unique about the atomic bomb, right? That maybe has happened with other things. I don't know, smartphones. Who could have imagined smartphones, and predicted the ways that they'd be in our lives, before they were, and maybe artificial intelligence, like, is another thing of just, well, it turned out surprisingly it was a lot more doable than people thought it was, even 20 years ago. And so, I don't know. I guess I think that I've gone over now my 30-second elevator pitch, but yeah, I think that in some ways this is just a feature of our human lives, is people, specialists, and things we've never studied or never thought about or never cared about, end up discovering or making something, even things they never even really intended. And all of a sudden now we find ourselves living in a different kind of world. And so I would say maybe like just approach it in this way, to think about one instance of that happening, that does very much still affect our world today. Like, we do still live in a world with atomic weapons, and to really see the story of how that comes about, and that it's a human story too, I think is hopefully compelling. It's compelling to me. Yeah.